For as long as we've looked up, Mars has captured our imagination, a steady reddish point of light crossing the night sky. Ancient civilizations saw it as a harbinger of war, a symbol of fiery gods. But as our telescopes improved, Mars became more than myth, it became a world. We saw signs of ancient water and wondered, could Mars have once hosted life? The dream of life on Mars didn't die, it evolved. We sent robotic explorers, rovers that became our eyes and hands on the Martian surface. Each mission peels back another layer of Martian history. We're journeying back to a time when Mars was warmer, wetter, and maybe, just maybe, alive. The story unfolding is more fantastic than any fiction. Imagine Mars not as a dusty desert, but as a world of blue water. Our rovers have revealed overwhelming evidence. Ancient lakes, rivers, and deltas shaped the Martian landscape. Curiosity, exploring Gale Crater, found rounded pebbles and mudstones, signs of long-standing water. Each sediment layer in Mount Sharp tells a story of a changing environment. Perseverance landed in Jezero Crater, targeting a river delta visible from orbit. It confirmed the delta's existence, finding layered sediments and boulders carried by ancient floods. Jezero was once a tranquil lake, a place where life could have flourished. These discoveries are the first chapter in Mars' story of habitability. Before we ask if life existed, we must ask if the conditions were right. Water is essential, the solvent for life's chemistry. Finding these ancient lake beds is like discovering a kitchen where life's recipe could have been made. The stage was set. The question, did any actors ever appear? Water was just the beginning. Life needs more energy, nutrients, and the right chemistry. Our rovers have uncovered a chemical treasure trove. Minerals formed by water and the essential elements for life. Curiosity's SAM instrument found sulfates, chlorides, and especially clay minerals, evidence of long-lasting neutral water. The presence of CHNOPs, carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur, means Mars had the raw materials for life. It's like finding a pantry stocked with all the basics. The rovers also found chemical gradients, potential energy sources for microbes. On Earth, some organisms eat rocks, thriving on chemical reactions. Mars had not just water and building blocks, but also the batteries to power life. The picture of a habitable Mars is coming into focus. The next step, searching for signs that life actually used these ingredients. The most tantalizing discovery? Organic molecules, carbon-based compounds, preserved in ancient Martian rocks. Organic doesn't mean biological, but all life as we know it is built from these molecules. Curiosity drilled into 3 billion-year-old mudstones and found complex organics, preserved against harsh radiation. Perseverance's Sherlock instrument mapped organics in Jezero Crater, often trapped in salt minerals. These molecules could have come from comets, geological processes, or, most exciting, ancient Martian life. We don't know the answer yet, but finding these building blocks is like discovering bricks at an ancient construction site. Were they just raw materials or the ruins of something more? Their presence is a profound clue. The search for life is now a search for the fingerprints left behind. Mars is keeping its secrets, but we're getting closer. With evidence of ancient lakes, essential elements, and organic molecules, we can finally ask, could Mars have supported life? The answer, yes, at least for microbes. Billions of years ago, places like Gale and Jezero craters were persistently habitable, much like early Earth. If life began, it was likely microbial, thriving in lake sediments and feeding on chemical energy. Microbial fossils are subtle, patterns in rock, clumps of organics, or minerals made by life. Our rovers can't give a final answer, I'm sure, but they're finding the best places to look. The real proof may require bringing Martian rocks back to Earth. We followed the water, found the chemistry, and located the building blocks. Now we stand on the threshold of one of humanity's greatest discoveries. These discoveries force us to see our own world differently. As astrobiologist Dr. David Grinspoon notes, we've only known one example of life, Earth. If we find even extinct microbes on Mars, it would revolutionize biology and our place in the cosmos. Mars and Earth were once similar, rocky, wet, and volcanic. If life started on both, it suggests life is common, not a cosmic fluke. If Mars is sterile, it means life's spark is rare, making our existence even more precious. Either answer reshapes our cosmic perspective. Science moves from speculation to testable questions. Was Mars habitable? Yes. Were the building blocks present? Yes. Are there preserved organics? Yes. The next question, are these organics biological? We are moving from philosophy to experiment, finally able to investigate one of humanity's oldest questions. Mars is our test case. The search is no longer just a dream, it's a real investigation. Our rovers have only scratched the surface, literally. Mars' harsh radiation likely destroyed delicate organics near the surface. The best evidence of ancient life may be buried deeper. That's why the Mars sample return mission is so important. Perseverance is collecting and caching the most promising rocks for return to Earth. Here we can analyze them with powerful tools, searching for biosignatures with unmatched precision. Future missions will drill deeper, reaching pristine layers untouched by radiation. The next chapter of Mars exploration requires us to dig. The search for life on Mars is about more than one planet. It's about our place in the universe. If life arose independently on Mars and Earth, it would transform our understanding of how common life is. The Drake equation's biggest unknown is how often life appears where conditions are right. Finding Martian life would suggest life is likely wherever the conditions are right. Billions of Earth-like planets could be living worlds. Even a single Martian microbe would change how we see the night sky, not as lonely, but as part of a vast cosmic biology. This quest continues the tradition of scientific discovery that has humbled and expanded our view of the universe. Each step, Earth, Sun, galaxy, has shown us we're not the center. Finding life beyond Earth would be the next great step, connecting us to something much bigger. The answer, whatever it is, will reshape our sense of belonging in the cosmos. We live in a remarkable time, sending our senses to another world, reading its history and asking if it ever harbored life. Curiosity and perseverance send us postcards from a distant shore, telling of a Mars that once resembled Earth. This journey belongs to all of us. When a rover drills into Martian rock, it's our curiosity at work. The images it sends, red dunes, layered canyons, pink sunsets, are a shared heritage. They invite us to look up, to contemplate our connection to the cosmos. So, next time you see that red star in the sky. Remember the story unfolding there. The story of Mars is part of our story. A story of exploration, discovery, and the timeless quest to know if we are alone